All right, thank you very much. Now I know a few people had some questions here already, and the questions can be directed at any of the speakers, or also our three panelists are quite expert at many of these questions. So there's a microphone around.
Sam, I noticed on one of your charts, I think it was BES element data, some of the feeds from that came from a list of utility providers. Was that meant to be an exhaustive list or just representative?
So in this case, it is exhaustive in the sense that they all come through the United States Reliability Coordinators, the 15 of them. There's 15, right?
Sounds right.
Sounds right, yes. Now, of course, the data is actually sourced from the PTs and CTs of the transmission and generation owners that own those assets, but it flows into us through the USRCs, the reliability coordinators.
Okay, so but there's not a block of any excluded today that are not participating. Is that correct, or there's
For
some?
the US, that's correct.
Okay.
All of the US is in.
Good. Okay, thank you.
Yeah, for the data threshold. Yeah.
Chris, from the bio, I believe that your company plays in the role of third-party financing. Can you speak to how your company or others may help enable the future grid faster or more efficiently?
Sure. Well, thanks for the question. What you're referring to is about energy as a service. So we look at, currently for large commercial customers, problems that they're facing are that outages are costly for them, right? They have, and also what we've seen within the industry is solar has become cheaper over the last decade, and when the price of natural gas has fallen a lot. And the reason I bring that up is because what's driving that now is we're seeing end customers saying, wait a minute, my outages are really costly to me. My definition of an outage is different. It's no longer current going to zero for 5 minutes. It's a fluctuation in voltage. And now I have options. Options being I can have generation units installed behind the meter at my site. So that's important because now we're seeing a big trend of people who like universities who have a high cost of an outage because of lost research. We see large commercial customers as well who have a high cost of an outage because of loss of production. And what they're doing is they're installing those very economical on-site generation assets, again, behind the meter on their site. Now, the problem they have is, hey, this is great. I'm going to have all this on here, but how do I pay for it? I didn't plan to spend millions of dollars to put this on the system. So there's been a lot of third-party capital that's come into the space over the last couple of years. So there's many private equity firms that have actually billions of dollars into this space that want to own and operate those assets. And then what they'll do with those actual end users, whether it be a commercial customer, university, they'll have some type of financial agreement. So there'll be like a lease payment to have those assets. There'll be some type of energy savings agreement. It could even be a power purchase agreement, depending on what state it's in. So my firm, we actually partnered with Duke's non-regulated team where, so Schneider, we designed and built the infrastructure, and then the Duke unregulated entity actually owns those assets, and they operate that system.
Microphone.
Follow-up question to that. Do you plan on moving that same model, that energy as a service model, also to the transportation space? So providing transportation as a service, in particular for electric transportation?
Yeah, so Nicole started talking about it in her presentation, and Jason mentioned with the buses, that's what's next. I mean, we're here in Orlando, so the Link system as well, they're going over to electric buses. And the real issue that the utilities face, and Jason hit it perfectly, even whether it be a school bus or regular public transportation, those buses, as they move going over to electrification, they're back in at the terminal at 5, 6 o'clock. So now you have these assets that need to be charged, and then also you have potential that they could interact with the grid. So I think that's really where we're going to see the next type of real big push is that today 60% of 60% of public transportation actually is some type of alternative fuel, and absolutely we're going to see the shift of fleets going over to electrification. And there is third parties that are interested, private equity firms that are interested in owning those buses, providing those buses to communities at no capital cost, and they're going to own them, operate those buses. I don't know, Nicole, did you have anything to add on that?
I might just add that I think part of the complexity is that the organizations or companies that own the assets that we're thinking about electrifying, so school bus operators or transit organizations, are not sophisticated energy market participants. And so companies like Schneider and Duke and others play a very important role as we try to move these assets towards the use cases where they're going to plug in and be compensated. And so if I'm a transit operator, my most important reason for existing is to get a person from point A to point B, and I need to make sure that I can fulfill that mission regardless whether there's power available to charge my bus or not at a given time. And so I think there's a resiliency aspect to what we're proposing or talking about.
Hey, I just want to make a comment before the next question. I just got a text from ChargePoint. They've stopped charging my electric vehicle back in Massachusetts because it's peak load time. So, the utilities are definitely on top of the EVs. All right. Next question.
I have a question for anybody on the panel to answer. So when it comes to energy storage, we mostly hear about batteries, and that's the cool thing to talk about. But I have a question about pumped storage. Do we see that taking off in the near to medium term?
Adarsh, probably that's a good question for you.
Sure. You're right. There's a common understanding that whenever somebody says storage, in the back of their minds, somebody tells them it's battery storage. That's what people think. But as I showed in one of my slides, storage, we call it the big S. When we say storage, that means it's not battery, it's everything. And regarding pumped hydro is one of the biggest, I would say. It's a lot. To be very specific, pumped hydro is geographically specific. And up till like few years back, pumped hydro was possible only if there was a water body nearby. But as of today, that's not true anymore. In fact, we at NREL already have a plan to make a pumped hydro happen in you can make it anywhere happen. You can just dig a trench and make a pumped hydro happen. So pumped hydro is actually one of the fastest growing and also already a highly present, significantly present storage type everywhere. Flow batteries is very big, to be honest. Thermal storage is going very well. Hydrogen-based storage is well. So it's like all sorts of storage are growing at all rates. So I think I want to make a clear point that as of today, I can make a confident statement that when we say storage, a lot of them are growing at the same time. Geothermal, thermal, pumped hydro, hydrogen, like compressed air, and all of them. So it's growing very well. And maybe somebody else want to answer.
So I'm not going to disagree. I think everything you said was correct. And one thing I will cite is pump storage is geographically located. Yes, you can build. We could go out and build a small version of it, but to get scale, where it's economic, you have to have a large amount of elevation change in a large body of water. So there are limitations around where you can see pumped hydro. We've done everything we can do in our service footprint area for pumped hydro, except for maybe one place. And now that's not proving to be very economical because of all the environmental regulatory issues that pop up when you now want to start doing that type of work. So what we have is a balance of what you can do from a technology perspective versus what is economically feasible to do versus for a price and a regulatory side. How much time are you really willing to spend to do that when you can look at other technologies?
I agree with Jason on that. Thanks.
So before the next question, I just want to interject one. I want to get Mike comment on this one. He mentioned that Resilient Grid has built all of this wonderful graphical user interface with all of this capability. And just before the session, we were talking about alarms and alerts. But it seems to me that when ISO New England has a problem with too much power on the grid, their curtailment activity is to make a phone call to our little town of Princeton, Massachusetts, and turn off our 2 little 1.5 megawatt wind turbines. Why aren't some of these things automated? I mean, can't this user interface be useful for giving those kinds of alarms and some of those things more automated?
Sure. So I think it's a great question. And ultimately, I think that we're seeing increasing amounts of automation all across the grid from, the edge to the central control room. One of the things that we find is that when you have, whether you'd call it over automation or we'd call it out of the loop, you start to have this problem where when you have systems that can perceive and process and data and execute commands faster than human beings even understand what happened, it pushes human beings out of the loop. And so as you see a lot of these technological advancements, just like you saw in aviation with the advent of the autopilot, you started to see a significant increase in fatal airplane crashes because the autopilot wasn't really designed with the human in the loop. For example, in my past work at ERCOT, we found that those phone calls on the sort of, residential level or sending out tweets or messages on Facebook or other things will get people behaving altruistically in ways that you can see scale up all the way to transmission loads. So sometimes the fully automated solution is not either good or bad in and of itself, but if it's designed without including humans in the loop, ultimately it ends up getting us into a place that we don't want to be.
Great. I know there was another question back here.
Yeah, so I comment before I do my question about the pump storage. I'm with Mark Johnson Barbie Salt River Project, and on the Salt River, we have several pumped hydro storage facilities, and we'd like to add more. One of the considerations is similar to some of the other things. Once those reservoirs were built initially for water storage, because we live in the desert and we need water. If you let it out to generate electricity, you're dumping your water downriver. So it's kind of a mix in terms of you're going to use it for energy or you're going to use it for storing water, which was what it's intended for. So kind of similar problems to other things we have with DERs, right? But my question is more for Nicole and Sam. It's Nicole, you were talking about microgrids, and we see that more and more, and at times I think it's better to talk people into what are your needs. I think that's a good approach. But as they're moving into microgrids, are you enabling the data to come off those microgrids into systems like Safner, I think you called it, Sam, that system, and do you want that data? Are you looking at taking Safner down into the distribution networks so you can get more detailed resolution of how the grid's working, even down to the distribution and microgrid level in the future?
So interestingly, we just had a conversation about this very question, and so NERC will, I think, and Sam will speak to their focus on the bulk power system. And I think also if you went to a number of the utilities, like maybe Jason can comment on this, the visibility from a data acquisition and perspective into distribution assets is depending on the utility is limited. So as we're adding these very smart assets like microgrids to distribution networks that may or may not have advanced to be able to interface with them, there is a disconnect there, an absolute disconnect. And so that's the question number two in my presentation that I was talking about. And then when you layer on the customer sophistication and whether they're able to, whether it's owned by a third party, which in many cases makes more sense because they're more sophisticated in controlling the smartness and interface of the various assets, the customer has a lot of impact there. And so how many loads are connected to a single microgrid and what is the functionality back into the distribution system. So I think the US and Canada in general don't have very good visibility into distribution networks.
So, and Nicole's absolutely right. To the first part is NERC is, our jurisdiction is statutorily limited to the bulk electric system, legally defined term. Roughly that's 100 kV and above with some inclusions, exclusions. Safner only receives live data for 200 kV and above facilities today. there is some discussion in the not imminent future that we may look to ask for some additional lower voltage data, but it's still going to be bulk electric system. I can't imagine in the foreseeable future that we would even entertain going down to those levels, because remember the sort of the customer use perspective. I'm looking at a North America wide scale, so a 3 megawatt microgrid campus nets out when you're compared to even the Texas interconnection at 65,000 megawatts total. Now that said, the one other thing that I'll mention is this concept of understanding and detecting these faint signals that could matter to your particular interest. There is definitely some value in that, and some of the things that I'm not using with these particular technologies because they don't quite fit my use case. I can certainly imagine other organizations doing it. When I was a system operator in Pittsburgh years ago, and we would have certain, not microgrids, but you could see where different universities and hospitals will start up their generation back. That would have been nice to know, because now I've got a distribution feeder in trouble. Things like that.
So I want to bring our ABB panelist into that discussion because ABB is one of the leading, or if not the leading, microgrid supplier worldwide, at least according to ARC studies. But the question is the digital grid. Can you explain to us how ABB, from a vendor's perspective, would see the digital grid and all the communication and standards and all the issues that make these things like microgrids play with the larger grids?
Sure. So the digital grid is going to be a critical enabler for the future grid. We talked a lot about decarbonisation and the role that renewables play in terms of sustainability. And then with that penetration of renewables, we also get this decentralized model coming into effect. And digitalization really is the enabling glue that holds those two factors together. From the base level, where what we've been doing in multiple industries and being applied now into the energy sector, where digital solutions can help operations and maintenance, which is a very easy use case to justify. But actually, as the digital grid or the future grid develops, you start to see the role that things like IoT and some of the advanced technologies, AI and machine learning, will play in helping to improve interconnection of grids, to help improve the ecosystem where we have new players, new prosumers coming on board. And you mentioned transactive energy. So how do we start trading electricity between non-traditional players? And then additionally, brand new markets and business models may open up based on that data. And that's a really important aspect, I think, for utilities especially, is how do they start to utilize this vast wealth of data that they're going to be collecting, and how do they start monetizing that data, both from their consumers, but also potentially to other areas, other utilities, in terms of like peer benchmarking. So I think digitalization is, we call it the 3Ds: decarbonisation, decentralization, and digitalization. Those three factors are completely synergistic, and they will really help define what the future grid looks like.
Any more questions?
Well, I might ask a question.
Oh, all right.
So to the panelists, do you think we're already using the data that we're collecting from advanced metering infrastructure, to the extent that we could, to facilitate some of the future electric grid that we're talking about here today?
I think the guy that's chuckling down there needs to answer that one.
So I'm chuckling only because AMI was sold as the future and the best thing ever. And everybody needs to do it. AMI is great, okay? But what we particularly did in a lot of cases is you say, yes, we're going to go out and put in automated meters. And that is wonderful technology. I'm now able to give you a remote connect. I'm able to give you 15-minute interval data. I can even give you 1-minute interval data. The problem is most companies aren't going to do that because we didn't build our communications network out the right way to be able to give you that type of information, because that would have cost 3 times the money. The meter was the cheap part. The communication system that goes behind it is the expensive part. And so I'm not even really doing, and again, we may be doing it now that it's been a few years. I look at emerging technology. I don't look at AMI stuff, but we're not even getting standard voltage that we could get. We're getting readings, kilowatt hour readings, but are we really going through and getting the voltage readings that we should? Because that could give us a ton more data, especially around power quality problems. But in the future, y'all may or may not know this, only 17% of the processing and memory capability is actually used on an AMI meter on average. And so what we're talking about when we unbundle and we take a system and make it more open, that means that potentially in the future, if one of my customers is having a problem, I can download an application to that meter over the air. And instead of having to run a truck out there to set a power quality meter, that's basically a power quality device. I mean, yeah, it's not exactly like a nice Schneider meter, but it is a nice power quality device. And just tell it, okay, speed up your sample rate just a little bit and then capture everything. And in 2 days, send all that information back to me over the air and then kill yourself off the meter itself. Those are the kind of things that we could be doing. We're just not doing them yet.
Any other questions? Because I know I have one more that I definitely have. And well, all right, we have a question at the front.
Jason, I think as you as well mentioned, E2G and VGI will be playing a big role in the future. Where do you think we are from a regulatory perspective, sort of timing of E2G being cost allocation?
You want to start?
Yeah. Okay. So you're talking about vehicle to grid. So vehicle to grid charging. So I mean, it's being done. I mean, today I've worked on a project where there was a fleet, and then the fleet would dispatch. Actually, part of it was for demand response. If the assets were there, they would discharge. I think what's tough on that, when you start using electric, I don't consider it policy is holding it up. I think it's on the technology side, because as you're using a vehicle battery system and you start charging and discharging it more, you're putting a heavier duty on those batteries. And I know there's some new statistics out there on some of the newer electric vehicles, but those cycles that you're hitting them with, I mean, that's degrading its life. It's something, I don't know, we just haven't seen it a lot. BMW is really progressive in trying to do that. It's a challenge, though. It's a challenge to find a fleet that you have not just of a couple kilowatts or hundreds of kilowatts, or you want megawatts, so you can go and dispatch that. So I don't see it on a policy side, because I think there is opportunities to go and use it for demand response or some type of other ancillary service. But it's not. I just don't see it as a policy side holding it up. I see it more of a technology piece.
Well, I'm going to give you the opposite answer.
Good. That's where the purpose of the panel is, right?
Because I think it is a policy side. Because I think that at some point, bigger companies like Duke or Schneider or others will actually own the battery in the EV, and you'll only buy the car without the battery. And then I will be able to, or Schneider or whoever, ABB or whoever, will be able to actually control those charging and discharging cycles with the knowledge base that you need X amount of charge to get to your workplace, get to whatever your schedule is. You can write schedules into your charging. That's not a big deal. But in order to take some of those technical hurdles out of the way and own the asset, so we can, as a utility, deploy it as needed, when it's needed, we may end up looking at owning the battery. And it'd be like a rental model. So you would rent the battery from us or lease it from us. And then when something happened, you wouldn't be responsible for replacing it. You would still need your X amount of kilowatts per hour or per day, or you need to drive X amount of miles, and that's the contract that you make.
After you.
Okay, thank you. And just further to that, there was a report I was reading a few days ago where they were actually talking about taking it a step further, where maybe whole car ownership model will start to deplete because of the fact that as EVs enter the market, the maintenance of an EV is minimal compared to a combustion engine car. And so it makes that leasing model really attractive. And so we may actually see more move towards that model, I think.
And I think from a totally different angle, it seems to me that there really are two different V2G paths you can go. There's the deplete the battery, push it back to the grid, warranty issues, ownership issues, and there's simply just more fine-grained load control. And when you have, basically a controllable load that can respond in less than 10 cycles and, can scale out to do everything from helping to manage inrush current for, HVACs or other kinds of system concerns, even if they don't become those large scale issues in terms of, worrying about depleting batteries, they still can provide, really significant stability enhancing services to the system.
Sorry for interrupting. My crystal ball is still cloudy on this, but it will be fleets that go first in that model.
Yeah.
But we've already seen there already was a company in Europe called A Better Place that tried this model. And it was going to be basically replacement batteries that you drove into like a gas station, and they just replaced your battery right there in under 15 minutes. There's another startup out of San Francisco right now called Ample, and they are doing the exact same thing, but they're putting about a megawatt worth of batteries that can be dispatchable back to the grid in each little place, and then have a little robot that comes out and changes out the battery for the passengers.
And Tesla bought Better Places technology when they went under, so.
Well, and I think just on the technology piece, and Chris, I'd be interested in where your perspective is coming from. The cycling and degradation of batteries hasn't been as much of an issue as the industry thought it was going to be, both in stationary applications and mobile applications. So I think that some of that is we're getting more comfortable with, and I'm speaking about lithium chemistries, as we're getting more comfortable with those chemistries, we're able to push the boundaries of their applications reliably.
Mm-hmm. No, yeah, I mean it's changing rapidly, the space, because the fleets that I worked on in Colorado for the V2G, it was a major degradation to those batteries. Now that was a couple of years ago, right? And things are changing with those chemistries, but we still see that the auto manufacturers, they do not. I should say they're selective on how they're used, right? They're very particular on those charge and discharge cycles. Now others aren't. Some other maybe more cowboyish style auto manufacturers said we can get a
progressive was the word
there
you're
you
looking
go.
for.
You can get 1 million charges and discharges, right? But I think it's exciting, right? It's exciting to see what's going to happen here. So I think it gives us more opportunities.
Well, and let's be careful about lithium.
Yeah, I agree.
Right.
Absolutely.
I mean, not
Absolutely.
from that, but from the standpoint of, it's not just the battery.
Yep.
It's all the ancillary equipment that goes with it. Because I'm finding out things. I mean, I run an R&D lab, and I'm finding out things. I've had 2 transformers burn up because I've put bidirectional flow changes from a battery 10,000 times through a standard distribution transformer, and we don't know what happens. Well, I do now. So 25-year life assets that we used to count on may not be there for us anymore. I don't know for sure that's what killed it, but I can tell you it's happened twice. And I put 10,000 bidirectional current flow changes for doing charging and discharging a battery. And, we're trying to use standard K levels, standard insulation levels on our transformers, and that's probably not the right call.
One of the other markets I just wanted to comment on this is that as electric vehicles become more prominent, some of them are going to get into wrecks, and those batteries are not necessarily useful for the other EVs on the road because their batteries are still all good. And so there is quite a number of companies, Mercedes was one of them, that was getting into repurposing batteries for second life use. Basically, end of life for an EV is about 80. When the battery loses about 20%, 25% of its capacity, it might be replaced. But there is a large inventory of used batteries that still have a fairly good life for stationary storage.
In fact, at NREL, we have a research going on looking at what sort of control systems should be developed for second life batteries in order to not kill the battery soon as to further extend the life of the battery. Yeah, that's on the table.
All right. We are now at the end of our time. You're welcome to well, first, I'd like to thank our entire panel. You are welcome to try to catch them at the end of the presentation. Well, there's one other thing I would like you to know. If you watch this presentation and you have the app, there's two things you can do. One is you can rate this particular session and the speakers. There's a second button for a survey of how your electric grid might compare to other electric grids. It's a very brief survey. I don't think that the way I've written the survey that anyone will achieve best in class, all right? Because you will have to be simultaneously have very low carbon emissions, also very high reliability, and very low cost electricity. And if you can get all three of those simultaneously, then you can be best in class. All right, hand for our panel.